Just wanted to show you the results of the other two Vector 3D STL files. We've got a bridging and overhang test. So this is the overhang, and that's what it looks like. Really happy with this gloss finish now that this completely smooth glass bed is giving us. I don't know whether you can see it or not. There is the tiniest amount of lifting right at the edge, and the gloss finish actually allows you to see that much more easily, because you can bounce the light off of this surface and you can see it's completely flat, and just at the end here the light refraction, it just changes. You can just see it in the light. I really don't think you're gonna, oh yeah, you see that line that's I'm moving around, just as that gets right to the end you can just see it change slightly, and you know there is a tiny little bit of lifting. And if I put it up on a straight edge, it's absolutely minimal, but it is there. So this prints 4 overhangs in each direction. You can see the axes are marked here, X, Y, plus and minus. So if this pops off, you've got a good, you know exactly where this was on the bed. What we're looking for here is, as the angles get higher, where is the line of a filament that just drops off the edge and starts to curl down. And what I'm printing with the equipment I've got, it's just impossible to print completely flat out into open air. But you can see in this case it's perhaps about there, and you'll probably find slightly different results on each side. It's just where the filament can't hold that horizontal line and it just starts to curve over right at the end. Spin it around again. So I suspect this is probably a perfectly normal and acceptable print. The instructions that this comes with tell you how to improve things if you need to. Layer height changes, maximum cooling. I'm sure different filaments will make a difference, but I mean really I'm not expecting anything better than that with what I'm currently printing and the cooling arrangement. So yeah, each overhang is unaffected by the previous ones because of the clever design. So yeah, very pleased with that. And once again I do like that nice smooth finish of the glass bed. Right, and then we've got this bridging test. Again, the axes are marked just in here, X plus minus. That's the top look, and then underneath. Now we did have a little bit of lifting here. You can see that that is rocking slightly in all, actually yeah, just in that direction, but it's more pronounced in that direction, which is the Y, I think. Well, not quite, is it? It's diagonal. So, and this is just testing the bridging capabilities, and you can see, see if I can get this to focus. You can see hopefully that it starts at the end, the correct thickness, and as we go across it starts to sag in the middle and then back up, and consequently they all sag after that, and that effect gets better as we get nearer the shorter lengths, obviously. Again, it's pretty much the same in all directions, and again according to the instructions we are talking about cooling, filament temperatures and speed, that sort of thing. Obviously the quicker that can fly across and the quicker it, the faster it can be cooled down, the less chance of it sagging. But again, I think this is probably an acceptable result, considering we're using all of the standard PLA settings. So I think they're really good tests. I think that £5 was very well spent, and the instructions were quite comprehensive and helpful. And I think we can now move on and start printing some things that are more useful. The calibration flower that I printed a couple of days ago has actually turned out to be a very nice coaster for a mug of coffee to sit on. So one of the first calibration STLs that you can actually use after printing it. So yeah, almost like that actually. You could probably use that as a very small coaster, but the calibration flower was perfect. So yeah, I would recommend going and have a look at Vector 3D and see if you think it's worth downloading the instructions, the Excel file, and these 3 STLs. Yeah, so there you go. Hope that helped.